So let's go ahead and pick up where we left off. So we took the second derivative, we set it equal to 0, and we factored, and I just realized that I factored this wrong. So this should be, I'm sorry, no, I didn't factor this wrong. I took the derivative wrong. The second derivative should be 24x. And then when I take this derivative, I'm sorry, second derivative set it equal to 0, I factor out 12x and I get x minus 2. So this is the correct steps here. X is equal to 0 and 2, and these are called my p-poise. They're not my point of inflections, they're my possible point of inflections. So what I need to do is I need to test them. And the way we test points of inflection is the same way we test maximum and minimums. I'm going to do another number line. Infinity, negative infinity, f, this time in the bottom it's f double prime. Or I'm sorry, I have it the other way around. F double prime on top, f on the bottom. And then now I can go ahead and use my p-poise as my critical numbers. These are my p-poise. P-poi. Choose the number in front of 0, behind 0, and after 2. So let's go ahead and test these now. Let's go ahead and use the second derivative to test the signs. Again, if the second derivative is positive, we have a up, concave up. If the second derivative is negative, we have a concave down. So let's go ahead and see f of negative 1. If I plug in negative 1 into my second derivative, I get 12 plus 24, and that is positive. So I have a positive second derivative. Positive, which means concave up. Next is 1. If I plug in 1, I can see clearly that it's 12 minus 24, which is a negative. So negative, which means concave down. F double prime of, what's the next number, 3. That is 12 times 3 squared minus 24 times 3. And that is 12 times 9 minus 72, and that is positive. Again, I don't want you guys to assume that we have alternating concavity here. That's not true all the time. But here we go. We have the answer to part D. I'm sorry, C and D. C, determine the intervals where f is concave up. F is CC up on negative infinity to 0 and 2 to infinity, because f double prime is positive. Notice that the reasoning is very much similar to the increasing decreasing reasoning. You have to use the calculus here. It's almost the exact same explanations, except now we're talking about second derivative and concavity. So f is CC down, concave down, on 0 to 2, because f double prime is negative. Now I don't have room for D, so I'm gonna have to erase. Well, I don't have to erase. Maybe I can just say this is D here. Now watch how I do D. Letter D says determine the inflection points. Inflection points occur when the graph changes inflection. It went from concave up to concave down, and then from concave down to concave up. So that means I have 2 points of inflection. So F has points of inflections, or points of inflection at x is equal to 0 and 2, because f double prime changes sign. That's it, changes sign. Now you could say changes from positive to negative, then negative to positive, and that could be okay. That could be a perfectly acceptable answer. In fact, that kind of answer is actually more better, because you're describing respectively what's happening at x equals 0 and x equals 2. But if you want to write very concisely, you can just say changes sign. F prime changes sign. You could even say at x is equal to 0 and 2 to be more descriptive. So there it is. There's your A, B, C, D done. Now let's go ahead and graph this and determine to see whether our information, our analysis is true. So here is the graph. I had to change the window. Notice that it's negative 30 in the bottom, 10 on top. So here it is. The graph is decreasing from negative infinity all the way to 0 because it flattens out at 0, which means I have a horizontal slope. That's my critical number. And then from 0 to 3, I'm still decreasing. And then from 3 to infinity, I'm increasing. So let's go ahead and see our notes. If we look at our notes, we see that f is increasing from 3 to 0, which is what we just showed, and decreasing from negative infinity to 0 and from 0 to 3. So yes, so far letter A is good, and letter B must be good because we only have one minimum at 3. You see there's no other minimum. This part here is not a minimum nor a max. It doesn't go up or down. It's not like a roller coaster. It just goes down and then down again, and then it goes up here, so that's a minimum. Concavity. Let's go ahead and take a look at the notes for concavity. F is concave up from negative infinity to 0 and 2 to infinity. So let's check. This graph has a U shape going up. Even though it isn't complete a U, it looks like half a U, but it's U, so that means it's concave up. It's shaped like a cup. And then it's concave down after 0, and then some point here it changes concavity because it goes concave down, and then some point here, I don't know where, changes back to concave up, and it remains concave up forever. And what are the points of inflection? We said that they were 0 and 2. So here it is, 0, concave down to concave up at 0, and then concave down to concave up. I'm sorry, concave up to concave down at 0, and then concave down to concave up at 2. And there we have our second derivative and the graph. So everything worked out pretty well. In the last example, we have sketched a graph of a continuous function with given characteristics. So we have to sketch a continuous curve, which means no holes, no breaks. So let's go ahead and look at the first one. So letter A says f of 0 must equal f of 2, which is 0. So that means that at 0 we have 0, and at 2, 1, 2, we have 0 again. The derivative is positive when x is greater than 1, which means that the derivative must be increasing when x is greater than 1. F prime of 1 is 0, which is a critical number. And we also have f the derivative is negative when x is greater than 1. So that means we should have increasing, decreasing like this, and f prime of 1, we don't know what f prime of 1 is, but all we know that f prime of 1 is a slope of 0. And notice this, it's f double prime is negative, which means that we have a concave down. So our graph should look down like this, or some sort of variation. Increasing before 1, decreasing after 1. The only possible way I can draw this is if I draw the graph like this. Increasing, decreasing, f prime of 1 is 0, which is a critical number, and it's concave down. I'll let you guys do letter B on your own since I'm running out of time. I'll see you guys in the next lesson.